In this video, we're going to talk about scientific theories. Scientific theories aren't necessarily like the ones you have in your daily life. The things you talk about in your normal life as theories are probably inferences. You might look at a car that's not running anymore and say, I have a theory about why that's happening. And then you check the oil, there is no oil, and your everyday theory was correct. It's not running because there's no oil. That's not a scientific theory. There's much more to a scientific theory. This cartoon, I think, illustrates well the misconception there is. The gentleman on the left says, evolution should not be taught in our schools. The science teacher says, well, why not? The guy says, because it's just a theory. And the guy responds, but isn't all of science just a theory? Well, that'll leave a lot more time for Jim. Of course, many people think that evolution is just a theory, like they have a theory about what's wrong with a car. But evolution is a scientific theory, like the scientific theory of plate tectonics, the scientific theory of gravity. And we'll talk about exactly what that means. So what does it take to be a scientific theory? First, you have to be well tested. There was a geneticist by the name of Barbara McClintock, and she worked with maize or Indian corn. She spent 5 years doing research, experiment, collecting data, going over and over and over multiple hypotheses until she came up with what she thought was a pretty coherent theory about what was happening in the genetics of corn and how it related to other organisms. When she finally presented her results, other scientists were completely blown away. They were 5 years behind. It took them a while to look at her evidence and figure out what she did to understand what was happening. That was a well-tested explanation. She did a lot of work, but it wasn't done. Other scientists came in and retested her experiments. That's when the theory got accepted by the larger scientific community. So a scientific theory is well-tested. It's not necessarily a hypothesis that has been proven right by one experiment. And when I say one hypothesis, a theory usually doesn't mean just one hypothesis. Usually, it unifies a broad range of hypotheses and observations. So it brings together a lot of things. So get rid of the notion that you have an observation, you turn it into an inference, you turn it into a hypothesis, and then your hypothesis eventually, graduates to become a theory. The first three were right. You do have an observation, you maybe make some inferences about it, and you can write a hypothesis about it. But your hypothesis does not graduate to become a theory. A theory unifies a lot of observations and a lot of hypotheses. Theories will also enable scientists to make accurate predictions in new situations. If a theory isn't functional, a lot of times it doesn't become legitimate. Because if you can't predict with your theory, how is your theory legitimate? All theories that are accepted by the scientific community can predict new situations, and they do so correctly. I like this picture. It's one of those demotivational posters. Gravity, just a theory. Of course, the sheep isn't floating in midair. It's a picture of a sheep jumping. If we were to continue through time, what would happen to the sheep? The sheep would be pulled down to the ground. We often call gravity a law. However, the difference between calling it a theory and law is simply that you can explain gravity with a mathematical equation. That is to say, gravity has an acceleration of 9.8 meters per second squared. But you can observe gravity in everyday life. Other theories aren't as easy to observe, but they're just as well supported. Some key scientific attitudes help scientists decipher through theories that are well supported and others that just don't have the support and maybe have some problems in their scientific methods. These are the 4 scientific attitudes: curiosity, skepticism, open-mindedness, and creativity. Curiosity is, of course, asking questions about the world around you. You're probably curious about things that you're interested in. You might ask questions about those things and wonder, what you can learn about them or what you can do with new things. Skepticism simply means you question the works of other scientists or professionals. You don't take them at what they say. If someone told you that they had a car that could go 0 to 60 in 2 seconds, you might not believe them because 2 seconds is really fast to go from 0 miles an hour to 60 miles an hour. So you'd want to see that. You want to see proof. You want to test it yourself. That's how scientists are. When they heard about Barbara McClintock's work, they didn't simply accept it at face value. They want to do the experiment themselves. Not necessarily to disprove all of her work and make her life meaningless, but they want to see if it really holds up, if they can reproduce the results. They are, however, open-minded. They're willing to accept new ideas that are supported. I once heard a story about a scientist who was, for years and years, saying to everybody he met that the Golgi apparatus didn't exist. It was fake. Someone was wrong. And then he heard a speaker who came in and gave really solid evidence for the Golgi apparatus. He walked up to the speaker afterwards, shook his hand, and said, "I have been wrong for years and years. Thank you for giving me the evidence." That's how scientists work. The reason we call theories just scientific theories and say that they could be changed by new evidence is being humble. We admit that we don't know everything, but according to what we know now, scientific theories that are accepted are true. Maybe we could find out something in the future that changes that, but we're willing to let ourselves be put out there so that we can progress. If we waited to find out every possible piece of evidence that could be found, nothing would progress in science. So we keep our minds open. If new information comes in, we have to think about things in a different way. And of course we have creativity, which is the ability to think in new and innovative ways. Scientists are faced with a lot of problems that don't have easy answers. So they really have to be able to think their way around these problems and design experiments in such a manner that they can be sure of the results they're getting. All four of these scientific attitudes are very important to scientists, and they shape how they function in daily life. These attitudes should be things that you do in science. You should be curious. You should have some skepticism about things. You should be open to new ideas, but you also should be creative, especially when thinking about experiments.